Welcome to qnawire.
For this problem on the topic of sources of magnetic fields, we are told that 4 long straight parallel wires each carry a current I0 and are located at the corners of a square which has side length d as shown in the diagram. We want to determine the magnitude as well as the direction of the magnetic field at the center of the square at point C. So the magnetic field at the center of the square is the vector sum of the magnetic field created by each current. Now, since the magnitudes of the currents are all equal and the distance from each corner to the center is the same, the magnitude of the magnetic field from each wire is the same. The direction of the magnetic field is directed by the right-hand rule, and we can see that in the diagram. Now, by symmetry, we see that the vertical components of the magnetic field cancel, whereas the horizontal components of each of these 4 magnetic fields add. So the resultant magnetic field at the center we'll call B, and B is equal to the vector sum B1 plus B2 plus B3 plus B4, as we can see in the diagram. So essentially multiplying the horizontal components, or rather adding the horizontal components, which gives us minus 4 times the expression for the magnetic field due to a wire, mu naught I over 2 pi r times the cosine of 45 degrees multiplied by unit vector I. So this simplifies to minus 4 into mu naught I divided by 2 pi, and we replace r by the square root of 2 over 2 times d multiplied by the square root of 2 over 2 times the unit vector I. And so we get the magnetic field at the center of the square to simplify to 2 or minus 2 times mu naught times the current strength I over pi times side length d along the unit vector I. And that's our magnetic field at the center of the square.